This is Dr. Brown. In this lesson, we're going to get into chapter 7.6 and talk about how to graph the sine and cosine functions and what their characteristics are. These are some of the things we're going to cover and the way we're going to cover. First of all, we're going to graph functions that are sine waves of the form y equal a sine of omega x, but we're not going to use transformations. We're going to use the calculator. We're going to graph functions of the form y equals a cosine of omega x, and again we're going to be using the calculator and not transformations. We're going to learn how to identify, determine what we call the amplitude and period of a sinusoidal function. And then we're going to graph sinusoidal functions, not necessarily using key points, but using the calculator. I'll show you a good method of doing this. And then we're going to look at finding the equation for a sinusoidal graph that would be presented to us. So let's go ahead and start by first looking at the graph of y equals sine of x. And what I have placed here on the left is a unit circle, and you remember going around the unit circle for the various angles that the y value is equal to sine of x, and the x value on the unit circle is a value of cosine of x. And notice that as we go around the unit circle, the period is 2 pi. Every 2 pi it repeats. Now, just looking at some typical points at x equals 0, the sine of x equals 0. So the point for sine of 0 is 0. So we have the point 0 and 0 on the graph of sine of x. Let's go ahead and then look at the angle pi over 6. At pi over 6, the value of y is 1/2. At pi over 2, the value, at pi over 2, actually, look at right here. At pi over 2, the value is 1. And at 5 pi over 6, the value is 1/2. Going on all the way to 2 pi, you come back to the value being 0. So these are the points we want to graph for our graph of sine of x. And we're going to do this also with the calculator. Notice that the sine function starts off at 0. In fact, the sine function at x equals 0 or theta equals 0 will always be 0. If it's just simply sine of x, the period is going to be 2 pi. In other words, we get a full sine function. The value, as we said, at pi over 6 is equal to 1/2. At pi over 2, it's 1. Then it begins to decrease, and at omega or x equal pi, we have 0. Then it goes negative and goes all the way down to -1, and then comes back to 0, and then repeats. What I want to do is take the calculator out and show you how to put this in your calculator, and we will look at various windows on the calculator just to see what's going on. So bring up your calculator, and we're going to clear the calculator and put sine of x in the calculator, and let's set the window up. To start off with, we're going to set the window up from 0 to 2 pi. And obviously in this case, the minimum value of the function is -1, so y-min will set it -1. Notice the function never gets below -1 and never goes above +1. So this should give us exactly 1 period. The other thing to be careful about is make sure you're in the radian mode if we're talking about radians for the angle. So the radian mode, we need to look at that. In this case, we are in the radian mode. And then now we can graph it. So now we are seeing 1 full period. Notice this is 1, 2, 3, 4, 5, 6. Well, 1, 2, 3, 4, 5, 6. And the end here is about 6.28, which is pi. The maximum value is 1, and the minimum value is -1. So now let's go and let's change the window so that we can see more than 1 period. Let's go maybe 3 periods, which would be minus 6 pi. That's 3 periods on the x equal negative values axis, and then go to 6 pi on the positive, and we'll keep the amplitude the same, and then graph it. And notice we see the same graph, except we see 3 periods on the left and 3 periods on the right. So remember that a sine wave always starts out at x equals 0 and begins to increase, then decrease, and it repeats. And the domain is from -infinity to +infinity. A pure sine wave can never get above 1 and never gets below -1. So the domain of the sine function is x from -infinity to +infinity. And you can see its domain is from -1 to +1. So here's a summary of characteristics of the sine function. The domain is a set of all real numbers. The range, which indicates how small or large the y values can get, is from -1 to +1 inclusive, or we could write y between 1 and -1, including the endpoints. Notice that sine function is an odd function. In other words, what you see on the right is a negative what you see on the left. So it is an odd function and has a symmetry with respect to the origin. The sine function is periodic with a period of 2 pi. And therefore you can see that the intercepts are going to be, just taking another look, the intercepts are going to be 0, pi over 2, 2 pi, and then multiples of pi. And the maximum of values of the function occur at pi over 2, 5 pi over 2, 9 pi over 2, minus 3 pi over 2. And the minimum values, notice the first minimum occurs at 3 pi over 2, and then that will repeat every 2 pi. So, as we said, 3 pi over 2, minus pi over 2, 7 pi over 2, keep adding 2 pi, and you'll see where the minimum values occur. Now we're going to look at the cosine function. You remember that the cosine of the function is going to be the x values. In fact, sometimes I would use cosine of theta instead of x, but it will be the x value on the graph. So notice that at the angle theta equals 0, the value of the x value is 1. In other words, this is x equal 1. So at pi over 3, notice that we get the x value is 1/2. At pi over 2, the x value is 0. And at 2 pi over 3, the x value is minus 1/2. And going all the way to pi, we see we're at minus 1. And then continuing, going to 3 pi over 2, we're at 0 again for the value of x. And at 2 pi, we're at 1. So now we can take these values and put them on the graph. And notice that the cosine function starts out at its maximum value of y equal 1. And then goes to its minimum value at x equal pi. And it goes through 0 at pi over 2, goes through 0 again at 3 pi over 2, and then gets back and completes a period after 2 pi. So graphing this, looks like I got 2 copies of this. The graphing this, the domain again is going to be any value of x or theta between minus pi and plus pi. Let's put cosine in our calculator. Let's put cosine of x. We're already in the radian mode. And let's go from minus 2 pi to plus 2 pi. And y min minus 1 and y max plus 1, and graph it, and we'll see now the cosine function. Notice that it always starts out with its maximum at x equals 0 or theta equals 0. So now we have similar characteristics for the properties of the cosine function. The domain is also the set of all real numbers between minus infinity and plus infinity. And the range is from minus 1 to plus 1 inclusive. And notice it's an even function and it's symmetric with respect to the y-axis. The cosine function is also periodic and has the same period as the sine function, and that is 2 pi. And then it goes through 0 at multiples of pi over 2. And the maximum value of the function is plus 1, and the minimum value is minus 1. Now, of course, sine of x and cosine of x, or sine of theta or cosine of theta, are not the only functions that we call sinusoidal. A function is sinusoidal if it looks like some constant value a times sine of omega x, where omega is called omega. And instead of using transformations, which takes a lot longer, we're going to use our calculator. And I'm going to show you how to go about figuring out what to put in the calculator. Now, first of all, we're going to really cover, graphing either a sine wave or a cosine wave. If omega is more than 0, we call the amplitude of these functions to be the absolute value of a. And the period, notice the period is going to change depending on omega. So if we look at the graph of a equals sine of omega x, if omega equals 2, x is not going to have to change as much to get around the period. So we have an equation here for the period. T is 2 pi over omega. So, for instance, if we had 12 sine of 10x, notice omega's 10, and the amplitude is 12. So the period would be 2 pi over omega equal 2 pi over 10 equals pi over 5. So that is the period. So when you look at the sinusoidal function, you'll need to determine what the amplitude is and what the period is, and that will help you determine what x min and y min should be. So here is my suggestion, or steps for graphing a sinusoidal function of the form y equal a sine of omega x, or y equal a cosine of omega x. You'll use the amplitude A to determine what your y min and y max should be. In other words, if y is equal to 10 sine of omega x, then you want to put maybe x min equal minus 10, y min equal minus 10 and y max equal plus 10. Then calculate the period 2 pi over omega and set x min is equal to minus 2 pi over omega and x max equal plus 2 pi over omega, and that will mean you will have 2 periods in your calculator. So let's graph y equals 3 sine of x. The period, obviously, is equal to 2 pi. And the amplitude is equal to 3. And let's put this in our calculator. Let's put 3 sine of x. And this particular function has a period of 2 pi. So let's go minus 2 pi to plus 2 pi, which is exactly what we have in here right now. And in order to see everything, make y min equal minus 3, because the amplitude is 3, to plus 3. Graph it, and notice that we get one full period on each side of the y-axis. Notice you can put your trace on, and you will get printed out the values of y. Notice we should expect at pi over 2 the value 3. You can always check that out by going second calc. Hit value, put in x equal pi over 2, and we should expect to see a value of 3, and sure enough we do. Now let's try to do another one. We want minus sine of 2x. Well, the amplitude is equal to 1. And the period, omega, is equal to 2. So the period is equal to 2 pi over omega is equal to pi. Now notice that we get one full period as we go from 0 to pi. And I want to put in our calculator y equals minus sine of 2x. And since the period is pi, we want to, if we want to show 2 of the periods, we'll go minus second pi. So minus pi to plus pi. And the amplitude here is 1, so minus 1 to plus 1 will allow us to see the full y values of the function. And now I hit graph. We see one period on either side. Now let's look at y equal minus sine of 2x. The amplitude is 1, the period is pi. I think we just did this, so I'm going to skip. Now, let's do another example here. We want to graph y equal cosine of 3x. Here the amplitude is 2. And omega is equal to 3. So the period is 2 pi over omega, which is 2 pi over 3. So let's put this into our calculator and graph it. Y equals 2 cosine of 3x. And the key thing is putting the window in. If we want to get a period on either side, get 2 periods, but let's go from minus 2 pi divided by 3 to plus 2 pi divided by 3, and we need to show an amplitude going from minus 2 to plus 2, and graphing it, we see basically what looks like a cosine function, but its period is 2 pi over 3. Now I'm going to show a sort of an interesting thing. Obviously, we've got drawn here cosine of function and cosine of function of x minus pi over 2. Notice the cosine function is in red and the sine function is in blue. But at the same time, the blue is cosine of x minus pi over 2, which basically indicates that the sine and the cosine function are the same thing, with one of them shifted to the right by pi over 2. So the sine function and the cosine function have identical graphs, but they're shifted with respect to one another. Now, we need to be sure we know how to determine the amplitude and period of sinusoidal functions. these two are going to be very simple. If we have y equal a sine of omega x or a cosine of omega x, the amplitude is the absolute value of a, and the period is equal to 2 pi over omega, where omega is what is multiplying the x. So in this case, this is an amplitude of 1, a period of 2 pi over omega, which is 1, is equal to 2 pi. This one is going to be the same, except the amplitude is 2. And of course, the period is equal to 2 pi. So for y equal a sine of x, we see one period of 2 pi, and it'll go up to plus a and go down to minus a. If we started out with y equal cosine of x and graph y equal cosine of 3x, the period is 2 pi over omega is 2 pi over 3. So graphing it, we see it having one period from 0 to 2 pi over 3. Another problem to work: what is the amplitude and period of y equal 3 sine of 4x? Obviously, the amplitude is equal to 3, and the period is 2 pi over 4 is equal to pi over 2. This just shows the answers we just put on the previous slide. Now we want to continue to be able to graph sinusoidal functions. Here we have an amplitude equal to 3. We have a period of 2 pi over omega with omega equal 4. So the period is going to be pi over 2. And I'm going to leave it to you to put this in your calculator and put in x min equal minus pi over 2 and x max equal plus pi over 2, and you should get this graph, except you'll see two lobes. You'll see from here to here. Notice, let's go ahead and do this, and we'll do this on the calculator. The amplitude, again, is 2. The period, t, is 2 pi divided by minus pi over 2. Well, of course, the period cannot be negative we need to put in the absolute value of what's multiplying the x, and that will be 4. So we expect one period to be 4, as you see here. Let's put this in your calculator. Remember, the period is 4. Put it in our calculator, and plug in 2 sine of minus pi divided by 2. And I want to be careful here. We need to use parentheses. Let me go ahead and put 2 sine, and I'm going to put minus pi over 2 in parentheses, and put in x, and close parentheses. Set up the window. We want to go from, since the period is 4, we want to go from minus 4 to plus 4. And since the amplitude is 2, we'll go from minus 2 to plus 2. Graph it, and we should see exactly what you see on the view graph here. So here is one period. Notice that it's a sinusoidal wave, but it goes minus sine. That's because of the sine of minus pi over 2. So it starts out at 0 and goes negative first, then comes positive, and then repeats. Now you can have variations of what we've already looked at. Let's look at this one. This has a sinusoidal function that's offset by minus 2. So just looking at the first part, it's going to go plus or minus 4. Subtracting minus 2 means it's going to go from minus 6 to 2. Let's look at the period. The period is 2 pi over omega, with omega equal pi. So it's 2 pi divided by pi equal 2. So the period is going to be 2. Let's go ahead and I will put this in the calculator. Y equals minus 4 cosine of pi times x minus 2. And the window now can go from minus 6 to plus 2. And we should see, and the x-men should go from, since the period is 2, go from minus 2 to plus 2. And the magnitude y-men should go from minus 6 to plus 2. Graph it, and minus 22. Notice I made an error here. The y-men or x-men should be minus 2 to plus 2, and I think the rest is correct. And now we see the graph. that shifted down, of course, and goes down to -6, goes up to +2 with a period of 2. Now, if you're given a sinusoidal graph, we need to be able to write an equation for the graph. So let's look at how we would find an equation for the graph shown here. Notice, we first of all want to identify what the period is. The period is equal to 4. The amplitude is equal to 2. And it's a sine wave because it starts out at 0, but it's going down first. So we want to make this a negative sine wave. So let's look at how we would set this up. The period is 4. So 2 pi over omega is equal to 4. So we get omega, solving for omega, we get 4 omega equal 2 pi. So omega equals pi over 2. So we're going to have sine of pi over 2 times x. The amplitude, remember, was 2, but since it's going down first, we'll make it -2. So now we need to graph this and then see that we get the same thing. So bringing up the calculator, we graph y equals -2 sine of pi divided by 2 times x. And let's set up the window. The period is 4, so let's go from -4 to +4. And the amplitude is 2, so we're going to go -2 to +2. And we should see the graph that we were first given, except, what is the syntax error? Somehow the 2 did not get in here. Pi over 2, close parentheses, times x, close parentheses. Now we should see it. So there's a function. It's a negative sine function, and it looks exactly like this. Let's do this one. What is the equation? The period t is equal to 1. So that means that 1 is equal to 2 pi over omega, which means omega equals 2 pi. And the amplitude of this is 3. So the graph would be y equals 3 cosine of 2 pi x. I'll leave it to you to put it in your calculator and verify that that is indeed the correct graph. And that is our lesson for today.